NENOMATICA, where mathematics meets YouTube excellence. In this video, we're going to solve an interesting geometry problem about a right-angled triangle. The problem states, Sarah was solving a geometry problem and discovered an interesting fact. She noted that in her problem, the triangle had sides of 3 consecutive integers, 3, 4, and 5, and this triangle was a right-angled triangle. Her older sister Mary asked if it's possible to find another right-angled triangle where the sides are also consecutive integers. In response to this question, Mary drew a right-angled triangle. She labeled the smallest side as x, and the other sides as x plus 1 and x plus 2. Let's draw this triangle. We'll place the right angle at the bottom left corner of our triangle. The smallest side, x, will be the vertical side. The middle side, x plus 1, will be the horizontal side. And the largest side, x plus 2, will be the hypotenuse. Now, to find the value of x, we can use the Pythagorean theorem, which states that in a right-angled triangle, the square of the hypotenuse equals the sum of squares of the other two sides. So we can write x squared plus 1 squared equals x plus 2 squared. Now, let's expand this equation to solve for x. On the left side, we have x squared plus the square of x plus 1. Let's expand this x plus 1 squared equals x squared plus 2x plus 1. So the left side becomes x squared plus 2x plus 1, which simplifies to 2x squared plus 2x plus 1. On the right side, we have x plus 2 squared. This expands to x squared plus 4x plus 4. Now, let's set these equal to each other. 2x squared plus 2x plus 1 equals x squared plus 4x plus 4. Let's rearrange to get our quadratic equation. 2x squared plus 2x plus 1 minus x squared minus 4x minus 4 equals 0. Simplifying x squared minus 2x minus 3 equals 0. Now we need to solve this quadratic equation. We can factor this as x squared minus 2x minus 3 equals 0. This factors as x minus 3 times x plus 1 equals 0, setting each factor to 0. Either x minus 3 equals 0, which gives us x equals 3, or x plus 1 equals 0, which gives us x equals negative 1. Since we're looking for a triangle with positive side lengths, we discard the negative solution. So x equals 3. Let's verify our answer by substituting x equals 3 back into our sides. The smallest side is x, which is 3. The middle side is x plus 1, which is 4. The largest side is x plus 2, which is 5. These are exactly the sides of our original triangle, 3, 4, and 5. In conclusion, we've shown that there is exactly one right-angled triangle with consecutive integer sides, the 3, 4, 5 triangle. Let's double-check using the Pythagorean theorem. 3 squared plus 4 squared equals 9 plus 16, which is 25. And 5 squared is also 25. Perfect! This is an interesting result because it tells us that the 3, 4, 5 triangle is unique in having both the consecutive integer property and the right-angle property. Thank you for watching this mathematical exploration. Welcome to this math video. Today, we're going to solve a problem about a rectangular field and find its dimensions using a system of equations. Let's start with our example problem. Let's start by introducing our variables. Let's call the length of the field x and the width y. Here's a diagram of our rectangular field. Since we know the area is 600 square meters, we can write our first equation. X times y equals 600. Also, the perimeter of a rectangle is 2 times the sum of length and width. Since we have 100 meters of fencing, 2 times x plus y equals 100. Next, let's solve the perimeter equation for y in terms of x. If we divide both sides by 2, we get x plus y equals 50. Rearranging to isolate y, we get y equals 50 minus x. Now, let's substitute this expression for y into our area equation. We have x times y equals 600. Replacing y with 50 minus x, we get x times open parenthesis 50 minus x close parenthesis equals 600. Let's expand this expression. Distributing x, we get 50x minus x squared equals 600. Let's rearrange to standard form by moving all terms to one side. We get negative x squared plus 50x minus 600 equals 0. Multiplying both sides by negative 1 to make the leading coefficient positive, we get x squared minus 50x plus 600 equals 0. Now, Let's solve this quadratic equation using the quadratic formula. We have it equals 1, b equals negative 50, and c equals 600. The quadratic formula states that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's calculate the discriminant first. We have b squared minus 4ac, which is negative 50 squared minus 4 times 1 times 600. That gives us 2500 minus 2400, which equals 100. Substituting back into the quadratic formula, we get x equals 50 plus or minus the square root of 100, all divided by 2. The square root of 100 is 10, so we have x equals 50 plus or minus 10, all divided by 2. This gives us x equals 30 or x equals 20. Now that we have two possible values for x, let's find the corresponding values for y using our equation y equals 50 minus x. If x equals 30, then y equals 50 minus 30, which is 20. If x equals 20, then y equals 50 minus 20, which is 30. So we have two possibilities, either x equals 30 and y equals 20, or x equals 20 and y equals 30. By convention, we usually define the length as the longer side of a rectangle. So the length is 30 meters and the width is 20 meters. In summary, we set xy equals 602 times open parenthesis x plus y close parenthesis equals 100. We solved for y equals 50 minus x and formed the quadratic equation x squared minus 50x plus 600 equals 0. We found that x equals 30 or 20 with corresponding y values of 20 or 30. Therefore, the field is 30 meters by 20 meters. For practice, try solving a similar problem with a field of area 840 square meters enclosed by 116 meters of fencing. Next, you could explore how to optimize the area of a rectangle given a fixed perimeter. Example, we will find the perimeter of a square when its diagonal measures 2 times the square root of 5. We'll display the problem, then draw an intuitive diagram. Let's sketch the square. The side length is unknown, call it x. The diagonal is 2 square root 5. Quick challenge, which theorem links side and diagonal in a square? Use the Pythagorean theorem on the right triangle formed by the diagonal. The legs are x, and the hypotenuse is 2 square root 5. So x squared plus x squared equals the diagonal squared. Simplify both sides. X squared plus x squared is 2x squared. The square of 2 square root 5 is 20. Therefore, 2x squared equals 20. Now isolate x squared. Divide both sides by 2 to get x squared equals 10. The side length is the positive square root. X equals square root 10. To find the perimeter of a square, multiply the side by 4. So the perimeter equals 4 square root 10. Example. In this problem, we will solve the radical equation x plus square root of x equals 6. We will follow a clear algorithm. Isolate the radical, square both sides, turn it into a quadratic, solve, and then check for any extraneous roots. Step 1. Isolate the radical. Move x to the other side, so the square root stands alone. Step 2. Square both sides to remove the square root. We square the left and the right exactly. On the left, the square and the square root cancel, giving x. On the right, we expand the binomial 6 minus x quantity squared. Step 3. Bring all terms to one side to get a standard quadratic. Then read off the coefficients a, b, and c and compute the discriminant delta. Step 4. Apply the quadratic formula. With delta equal to 25, the square root is 5. So x equals 13 plus or minus 5 over 2, which gives the candidates x equals 9 and x equals 4. Step 5. Check both candidates in the original equation, because squaring can create extraneous solutions. 4x equals 9. 9 plus square root of 9 is 12, not 6, so 9 is extraneous. 4x equals 4. 4 plus square root of 4 is 6, which works. Only x equals 4 is valid. Example. In this problem, we will find the dimensions of a rectangle from a word description. The length is 3 more than 4 times the width, and the area is 45 square meters. We will define a variable for the width, build the area equation, and solve a quadratic step by step. Let's visualize. I will draw a rectangle and label the shorter side as a, the width, the longer side, The length is 4 plus 3. The area is width times length. Now translate the words into an equation. Width times length equals 45. That is a times the quantity 4, a plus 3 equals 45. Expanding gives 4 squared plus 3 equals 45. Move everything to one side to get 4 squared plus 3 a minus 45 equals 0. We will solve the quadratic with the quadratic formula. First compute the discriminant delta equals b squared minus 4ac. Here the coefficient a is 4, b is 3, and c is negative 45. So delta equals 3 squared minus 4 times negative 45, which is 729. Apply the quadratic formula. A equals negative b plus or minus the square root of delta all over 2a. Substituting gives it equals negative 3 plus or minus 27 all over 8. The roots are 3 and negative 15 over 4. Because a is a width, we keep the positive root equals 3. Now compute the length using 4 plus 3. We keep the positive root equals 3. Now compute the length using 4 plus 3. That is 4 times 3 plus 3, which equals 15 meters. Quick check. Width times length is 3 times 15, which equals 45 squared. In this video, we will solve the classic handshake problem step by step. In a meeting, everyone shakes hands with every other person exactly once, and the total number of handshakes is 66. How many people attended the meeting? Let's build intuition with a small example. Imagine 6 people around a circle. One person can shake hands with 5 others. Counting every unique pair exactly once is the same as combinations of x people taken 2 at a time. We are told the total number of handshakes is 66, so we set the handshake formula equal to 66. That is, x times x minus 1, all over 2 equals 66. Now solve for x, multiply both sides by 2. Expand the left side. Move everything to one side to get standard quadratic form. Next, we factor the quadratic. X squared minus x minus 132 factors as left parenthesis x minus 12 right parenthesis times left parenthesis x plus 11 right parenthesis. Set each factor to 0 to find the solutions. Because the number of people cannot be negative, we discard negative 11. So x equals 12 people. Let's quickly check. 12 choose 2 equals 12 times 11 over 2, which is 66. It matches. Final answer. There were 12 people in the meeting. 12 people. In this example, 2 cars start from the same point and travel at right angles. Car A travels north at 25 kilometers per hour starting at time 0. Car B starts 2 hours later and travels east at 20 kilometers per hour. After how many hours from the start of car A will their separation be exactly 300 kilometers? We'll model the motion, write the Pythagorean distance equation, expand, and solve the resulting quadratic. Let's build a clean diagram. The green point is the common starting point. The vertical blue arrow shows car A's northward distance, which is 25t. The horizontal purple arrow shows car B's eastward distance, which is 20 times the quantity t minus 2. The dashed red segment is their separation, which should be 300 kilometers. The paths form a right triangle, so by the Pythagorean theorem, legs squared plus legs squared equals hypotenuse squared. Expand each square carefully. Compute the inner square. Combine like terms on the left. Move all terms to one side to write a standard quadratic in t. Now apply the quadratic formula with a equals 1025, b equals negative 1600, and c equals negative 88,400. Compute the discriminant and simplify. Divide numerator and denominator by 50 to neaten the expression. Time must be positive, so take the plus root and evaluate numerically. Therefore, about 10.1 hours after car A starts, their separation reaches 300 kilometers. On the diagram, that corresponds to the dashed red hypotenuse labeled 300. Separation reaches 300 kilometers. On the diagram, that corresponds to the dashed red hypotenuse labeled 300. In this example, we'll solve a classic work rate problem using a clean step-by-step approach. Here is the problem statement. 2 packaging machines, A and B working together can fill a certain batch in 2 hours. If they work separately, machine B takes 1 hour longer than machine A to complete the same batch. How long does each machine take when working alone? Let's visualize the situation. We'll draw machine A and machine B, a job bar representing one full batch, and show that together they finish the single job in 2 hours. Step 1. Let T be the time, in hours, for machine A to finish the job alone. Then machine B requires T plus 1 hours to finish the same job alone. Step 2. Convert times to rates. Rate is 1 over time for one job. So in 1 hour, A completes 1 over T of the job, and B completes 1 over T plus 1 of the job. Step 3. Together they work for 2 hours and finish exactly one job. That means 2 times 1 over T plus 2 times 1 over T plus 1 equals 1. Step 4. Multiply both sides by T times T plus 1 to clear denominators. Step 5. Expand and combine like terms to get a standard quadratic equation. Step 6. Solve the quadratic using the quadratic formula. For it equals 1, B equals -3, and C equals -2. Step 7. Time must be positive, so we take the plus root. T equals 3 plus square root of 17 over 2, approximately 3.5616 hours for machine A. Then machine B needs 1 hour more, which is about 4.5616 hours. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.